This video is about determining equilibrium constant from changes in concentrations. Let us look at this example. A 2.0 dm cube sealed container contains 2.40 moles of hydrogen iodide, which decomposes at a certain temperature according to the following equation. At equilibrium, the concentration of hydrogen iodide is 0.935 moles per dm cube. What is the equilibrium constant, Kc, for the reaction at that temperature? To determine the equilibrium constant, we need to know the equilibrium concentrations of hydrogen iodide, hydrogen, and iodine. However, only the equilibrium concentration of hydrogen iodide is given in the question. How do we find out the rest? To start with, we can find the initial concentration of hydrogen iodide. Initially, there is 2.40 moles of hydrogen iodide, and the volume of the container is 2.0 dm cube. Divide 2.40 moles by 2.0 dm cube. We get the initial concentration of hydrogen iodide, 1.20 mole per dm cube. Then set up an ICE table of concentrations. Work out the initial, change, and equilibrium concentrations of each reactant and product. From the initial and equilibrium concentrations of hydrogen iodide, we can find the concentration change of hydrogen iodide by subtracting 1.20 from 0.935. We get minus 0.265 moles per dm cube. According to the equation, when 2 moles of hydrogen iodide decomposes, 1 mole of hydrogen and 1 mole of iodine form. So the change in concentration of hydrogen is plus 0.265 divided by 2, which is plus 0.133 moles per dm cube. The change in concentration of iodine is also plus 0.133 moles per dm cube. The equilibrium concentrations of both hydrogen and iodine are 0 plus 0.133, which is 0.133 moles per dm cube. Now we get the equilibrium concentrations of all the substances we need. Now write the expression for the equilibrium constant. Hydrogen and iodine are the products of the reaction. Write their equilibrium concentrations as the nominator. Hydrogen iodide is the reactant. Write its equilibrium concentration as the denominator. The stoichiometric coefficient of hydrogen iodide in the balanced equation is 2. We have to add the power 2 to the equilibrium concentration of hydrogen iodide. Finally, substitute the equilibrium concentrations into the expression for the equilibrium constant. We get the value of 0.0202. Note that the equilibrium constant in this example has no unit. This is because the sum of the powers of the numerator is 2 and that of the denominator is also 2. The concentration units cancel out in the expression of equilibrium constant.